Hi, welcome to my video on evaluating limits, extra problems number 2. We're going to look at the limit on sine, cos, and tan, and sine and cos with different periods. So number 1, the limit as x approaches 0 on cos of x. Well, the period of cos is 360 degrees, or we could say 2 pi. So if we establish, I'm going to look at it in terms of degrees because degrees makes it easier. So if we put 360 here, 180, and make this a negative 180 and negative 360, the period is divided into 4 parts. So the sine of 0 is 0. The sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. Make that a negative 1 there. And sine of 360 is 0. And if we go this side, that's negative 90, so the sine is negative 1. Sine of negative 180 is 0. Sine of negative 270 is 1. The sine of negative 360 is 0. So the sine graph is a sideways S. So notice. So if you go from 0 to 360, it's a sideways S. So what happens as the sine graph approaches 0? On the right side, as it approaches 0, we get a 0. As we approach 0 on the left side, we have a 0. So the answer is 0. So the limit is, I got 0 at a degree. That should just be 0 as a value because it's in terms of degrees or radians. So x is in terms of degrees or radians, so the value is 0. Now, what about the cos graph? Again, the period of the cos graph is 360, or we could say 2 pi in radians. So let's make this a 360, 180, negative 180, and negative 360. So the cos graph, the cos of 0 is 1. So the cos of 0 degrees is 1. The cos of 90 is 0. 180 is negative 1. 270 is 0. And 360 is 1. And when we go to negative 90, we get a 0. Negative 180 cos is negative 1. Negative 270 is 0. Negative 360 is 1. So the cos graph is like this, going over this interval of negative 360 to 360. So there's the cos graph. And again, the period is 360 divided into 4 equal parts of 90, 180, 270, 360, and etc. 4 intervals here. And as the cos graph approaches 0 on the right, we get a 1. As the cos graph approaches 0 right here, as the degree goes this way, the graph is moving up, approaching 1. So the limit is 1. To the right is 1, to the left is 1, so the limit at 0 is 1. Now, what about the sine of 2x? Well, we have a 2x, so the period of 2x, the period of sine is 360 divided by 2, so that makes this period 180 degrees. So if we say this is 180, and we make this a 90, and we make this right here negative 180, and make this a negative 90. So we want the sine of 2x as it approaches pi over 4, and pi is 180, so that's approaching the 45 degree. Notice I'm working in degrees. Degrees are easier to work with. So pi over 4 is 180 divided by 4 is 45. And so 45 is right here. But what happens between 0 and 360, way out here, there's two sine. It says sine of 2x, so there's two of them between 0 and 360. So this is only one of them. So at 0, right here, at 90, this is a 45, we get a 1, 0, negative 1, 0. So this is, so notice again between 0 and 180 there's one cycle, and there's another one between 180 and 360, and again there's two of them. So what about if we go this way? So we get negative 1, 0, 1, 0. So again, on this side is half. So between 0 and negative 360, there's two repetitions, cyclic. And we want to work it out as at 45. So at 45, when we approach the 45 on the right side, we get a 1. As we approach the 45 on the left side, we get a 1. So the answer to this one is a 1. Another way to do that would be to take the sine of 2x and write down 2 times pi over 4. So this is the sine of pi over 2. So this, when I look at it, this sine of 2x, I'm looking at the graph of the sine of 2x. But if I sub in pi over 4, I get sine of pi over 2. And if we look up here, the sine of pi over 2 is 180 divided by 2, which is 90. We get a 1. So if you do it this way, you quickly get a 1. If you do the graph, then it's more understanding, and it explains what the sine of 2x is doing. So either or, you can graph it, or this is the fastest way. Now, what about finding the limit of the tan of x as x approaches pi over 2 on the plus side? That's on the right side. So pi over 2 is 180 divided by 2, which is approaching 90. So the tan graph, the tan at 90, 180, 270, 360. So the period of the tan graph is 180 degrees. The period of sine is 360, the period of cos is 360, but the period of tan is 180. So tan is undefined. The tan of 90 is undefined. The tan of negative 90 is undefined. The tan of 180 is 0. The tan of 0 is 0. The tan of 270 is undefined. And again, the tan of negative 270 is undefined. So the tan graph, if you remember, goes like this. That's 1. And then it goes again, because it keeps repeating itself every 180 degrees. So, what about the limit as x approaches 90 on the positive side? So this is approaching 90, going this way on the positive side. So this tan graph is going to negative infinity. If we were approaching the 90 on the negative side, on the left side, it would be approaching positive infinity. And another one to do, the limit of the cos of 3x as x approaches negative pi over 2, negative 90. So the period of cos is 360, and it's 3 is the number, so the period is 360 divided by 3. So the period is 120, or we could say the period is 120, and we multiply by pi over 180. The zeros cancel. 6 into that's 2, 6 into that's 3. So 120 is 2 pi over 3. The period in degrees is 120, in radians is 2 pi over 3. So the period is 120, so let's do degrees. 120 and a negative 120. Divided into 4 parts, so that's a 60, and that's negative 60, and that's 30, and that's 90. That's negative 30. That's negative 90. So let's look at the cos graph. And the cos graph, there's three of them between 0 and 360. So this is just one of them. So the cos graph of 0 is 1. If you put 30, 3 times 30 is 90. The cos of 90 is 0. Put 60 in, you get 180. The cos of 180 is negative 1. 90, 3 90s is 270, which is a 0. And 120 times 3 is 360, which is a 1. So this is the cos graph doing this. And on the other side, we get 0. We get negative 1. We get a 0. And we get a 1. So that's the cos graph. Again, from 0 to 120 is 1. Part of the cos graph, and we have 3 of them. And we want to look at as it approaches the negative 90. Negative 90 is here. So as you approach it on the right side, it goes to 0. As you approach it on the left side, it's approaching 0. There it is. And another faster way, the cos of 3x is the cos of 3 times negative pi over 2 is negative 90. So that's the cos of negative 270. And if you look at the cos graph, the cos of a negative 270 is right here, 0. Again, this is the faster way to do it because you're just looking at the cos graph. If you look at this graph, then you still get the same answer, but it's a little bit more to the understanding of the sinusoidal functions unit that we did. Okay, let's look at some more. What about we look at the limit as the arc sine or inverse sine of x as x approaches 1 on the left side? Well, to do that, let's look at the sine graph. So this is y equals sine x. Now, this x can get confused, but let me explain. Let's cover this up for a second. Let's look at the sine graph in terms of y equals sine x. The sine graph is 0, 1, 0, negative 1, 0. So I have it memorized. So, and we keep on going. That's negative 1, 0, 1, 0. So this is the sine graph, but we want to look at the y equals sine negative 1 of x. And so that means the x and the y's are switched around. So this is the y, and this is the x. I should put an x there and a y there, even though I have an x written in here, but if the x's and the y's are reversed, so the domain, which is x, becomes the y, and the y becomes the x. So this is the y, and this is the x. So they're switched around, okay, when we do an inverse, but because this fails the horizontal line test, when you draw a horizontal line, it passes through more than one point, so we have to restrict it. So the sine graph is restricted in this interval. So on this interval, from 90 to negative 90, or from pi over 2 to negative pi over 2, this is the interval the sine graph is restricted. So this point here is 90 and a 1. And again, I'm using degrees to make it easier. So hopefully you can see in terms of degrees, I could use radians, pi over 2, negative pi over 2. So when you flip this around, this becomes the domain becomes the range, and the range becomes the domain. So this is a 90. This is negative 90. And right here is a 1. And this is negative 1. So when you reflect this in the y equals x, when you reflect this part of the graph in the line y equals x, the x and the y flips. So the 90 becomes the y, and the y becomes the x. And this point here is right here. This point is -1, -90. And when you reflect it, it goes through 0, so it's doing this. And you need to reflect it in the line y equals x. So this part of the graph, restricted here, is the inverse here. So in terms of the inverse, we're looking at the arc. So as it approaches 1 on the negative side, as it approaches 1 on the negative side. So this is approaching 1 on the negative side, so we get a 90. And the 90 is a pi over 2 if you want to keep it in terms of radian. Now, interesting one, what about if you approach 1 on the positive side? So in terms of the inverse, as you approach 1 on the positive side, you can't. So the limit does not exist. Does not exist. So you can approach 1 on the negative side to get a 90, but you can't approach 1 on the positive side in terms of the inverse. Okay, let's look at one more. What about the arctan of cos as x approaches -1 on the positive side? So let's look at the cos graph. The cos graph of 0 is 1, 0, -1, 0, 1. So that's the cos graph right here on the right side. So this is a 0, -1, 0, 1. So here we are. So this is the cos graph. And the cos graph, again, if you want to look at its inverse, which is arc, -1, we draw a horizontal line, you can't do it. Yes, we can draw a horizontal line, but it passes through many points, so it fails the horizontal line test. So we had to restrict it. So the restriction comes from here. We trace it out and make it darker. There's the restriction. So restriction is from 0 up to 180. And it goes from 1 to 0 to 180. Oh, I got to be careful. I'm doing this restriction. So this point here is 0, is that's 0 to I'm kind of ahead of myself now. This is 180 here. This is a 0. And this is a 1. So 0 gives me a 1. And this is right here. 180 gives me -1. So when we do the restriction for its inverse, we look at this interval. So that means 0 to 1 is 1 to 0. So we make this a 1, and we make this a -1, and this is the 90 in the middle here. This is the 180, and this is the 0. So this point 0, 1 becomes 1, 0, which is right here. And this point here is 180, -1 becomes -1, 180. So that's that point there. That point becomes -1, 180. So the restriction, if you look at it, it goes like, so this restriction, in order to look at the inverse of arc cos, so here it is, there's the restriction. So there's his inverse right there, going from -1 to 1. Notice the domain is from 0 to 180 here. It's the range right here on the y. And the range goes from 1 to -1. That becomes the domain from 1 to -1. So now that we have the restriction right here, there it is. Look at the graph by itself. Now, what about as you approach negative 1 on the positive side? We're approaching negative 1 on the positive side. So that's coming as we go along here. The curve is going like this. So we get 180, which is pi, if you want it in terms of radian. So I wanted to do a few on inverses to hopefully makes it a little bit clearer when you look at the inverses. But I like to, I haven't memorized what the restrictions are and what the graphs are doing, so it's easier for me to do. Hopefully you have it memorized. That brings us to the end of this video. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.